So here I'm going to start with some numericals on galvanometer. I think these are very important for understanding the concept of, say, galvanometer. So for that, I'll first take up a question, say, just to understand how to find out the direction of the torque. I'll assume that some details, say for example, it is given that magnetic field is given as B is magnetic field that is given as 5000 Gauss is 5000 Gauss, and the direction of the magnetic field is given as K, so that means it's along Z direction. So these are some quantities which are given in the question which I'm writing here. And then in the question he has said that second quantity that is given, that there is a coil and the dimensions of the coil, or he has written area of the coil, that is equal to 10I plus 10J, and these units are in centimeters. This is also given in the question. Then third thing that is given in the question, it is said that current carried by the coil is 10 ampere. Now, this is what is given in the question, and we have to find out the direction of torque. We have to find out torque and its direction. So that means torque is to be calculated. We have to find out the direction of torque. So in order to actually solve this question, I'll draw a diagram by which we can say try to understand what is to be done in this question. So therefore I'll move on to page, assuming that we remember all these details. We have to remember these details because we must know what is to be derived from the question. So for our for this question we are supposed to find out the torque. So I'll draw a diagram so that we can understand the things to be done. Okay, let's suppose that this is the magnetic field. I'll take this as direction K or Y direction. I'll take this as X and this as Y. Even you can do that or you can interchange that, but I'm doing it this way. So that means this is I, this is J, and this is K direction. It's also given that current is there, and I'm representing that current by a different color so that you can, the current is going in this way. So this is direction of current that's moving in the loop, and we are supposed to find out the torque. This is magnetic field. We know that magnetic field as per the given question B, that is given as 5000 Gauss, and we know that in order to convert it into Tesla, 1 Tesla is equal to 10 to the power 4 Gauss. So that means Gauss is a very, very small unit. If I'll convert that, I'll write B, therefore will come out to be 0.5 Tesla. Of course, it has a direction given like here. So I'll write that it is in the direction of K. Now I'll move on to other, because we know that मेरे पास जो the formula which we have got torque, that's equal to, there is a single coil, otherwise we have NIAB, that's NIA cross B. So vector quantity, this is a vector quantity, this is a vector quantity. N I A B. N is number of turns, number of say turns. Here we are having a single loop, so therefore here I'll see what is given in the question. So therefore in the question n is given as 1, so nothing to do with that. I is given, that is 10 ampere. Then area is, right, area is, that is 10 into 10, 10 centimeter, so therefore 10 divided by 100, so you'll convert it into, that is 1 by 10, 1 by 10 meter into 1 by 10 meter, so therefore that comes out to be as 1 by 10 of a meter, 10 centimeter into 10 centimeter, so therefore that will be equal to 0. That's 1 by 100, so 0.1 meter square, so that will be area. Okay, so that means we have got everything. Now we want to find out the torque. So therefore we'll write torque is equal to, n is not there, I is 10 ampere, and the area is 0.01, that is given there. I into a is a vector quantity also. I have to find out the direction. So for that, you remember that the grip rule, if we are having current in this way, so that means torque will be represented, magnetic moment will be represented by this. So I'll write that as K. In R, we were having this as X, this as Y, so that means this will be the direction of K vector, that is the magnetic moment. So therefore I'll write that as K. Now we have torque is equal to I into A cross B, and B is 0.5 Tesla, and that's also K. Now in that case we'll write torque is equal to, because we know that K cross K is how much, that is 0, so therefore we'll write there is no torque. So that means you could find out torque, and the torque will be 0, so that means this coil in that case will not represent any, or will not experience any torque. But there could be other situations in which it may experience a torque. I'll say for example I'll change the orientation of this coil so that you can find out now what should be the direction of torque. I'm doing it here. Say for example, if I'm changing the direction, now you can accordingly see that whatever the question is asked, you can find out the torque. Say for example, in my question I'm changing the question. Say I'll take one more case. In the second case, I'm assuming that we are having this as the coordinate system. This is again z direction, and magnetic field is given here, and we are having this as 10 centimeter, this is 10 centimeter, and this is 10 centimeter. So that means here you can say that if I'm taking this as, say for example, y direction, this as x direction, this is z direction, or you can take this as x, and suppose the current is going in this way, current is going in this way. Now in this case, if you'll again apply the grip rule, or you'll say that magnetic moment will be pointing in this way, magnetic moment will be along this direction, so that means along x direction. So therefore you'll write torque is equal to, the numerical values will be same, say for example 10 ampere into area is 10 into 10, so that was coming out to be 0.01, and its direction will now be, say if I am writing this as x, so therefore that will be I cross, because torque is equal to, this is I into A, and cross magnetic field. So magnetic field was 0.05 Tesla. So that is therefore this is I into A. I'll remove it here, otherwise it will create a, so I'm removing it here. So therefore you'll write torque is equal to Z10 into 1, so that is 0.01, Z10.1, say into 10, that is this 10 into magnetic field, that was 0.5 Tesla. And now direction is, because this is in K direction, and you know that um, if you want to find out direction of this, so right, therefore torque is equal to, first these numerical values, this is 0.5 into say that is 5 into this, so therefore it will be 0.05 Tesla meter square ampere. Ampere for current, area, and Tesla meter square. So we call this as torque also, or if you want you can take it out, you can write simply as Newton meter into, then you have to write its direction, and direction I'll write because I have to find out the direction of different. So this is x direction, that's I cross k. So I'll write therefore I'll remove this here and I'll write it as I cross k to find the direction. So therefore it will come out to be 0.05 into, you know that if it is I, j, and k, to remember the, this is I cross j, that's equal to k, j cross k equal to I, and here you have got I cross k, so that will be equal to minus j. So therefore you have been able to find out the direction of torque here. So that means in some cases there may be torque, in other cases there may not be torque, but this is how you do it. Now I'll move on to next question. I'm again taking some details. The questions will be similar. In fact, I have a question here, and this question is from CBSE and has been asked a number